Hello, we're going to continue now with our set of exercises based on the different problems involving the subject engineering economic analysis subject. Okay, for today we're gonna until today we've been dealing with different instruments for assessing the projects, and today we're going to focus in the benefit cost ratio as an instrument for assessing and checking if a project is worth doing or not. There are two ideas that I would like to take into account that were included in the theory. First one is that you have plenty of information about the project, but you have to summarize everything into a ratio. This ratio, in the case of benefit cost analysis, may produce inconsistent results depending on the assumption. We'll see that. So the purpose of the exercise is to realize how the correct analysis with correct data may produce different indicators if they are not used the same way. Okay, so it will be important that you're familiar with the theory before watching this video. The second point I would like to remind is that we're gonna use again the Maxima package that you're I presume you're already familiar with. Okay, let's start then with the project. Okay, this is the example we have. Let's go into the exercise. It's here. So first of all, I will take care of checking that Maxima is open inside the document and the package has been applied. Okay, so let's come here to this result. Okay, we have this exercise for the moment. We see that if we go through the information we have, is we read that the city of Columbia is considering extending the runways of the municipal airport so commercial jets can use the facility. And then there is a long description here of all the costs associated with the process. Some of the costs are annual costs to be considered, some others are just investment, pure capital cost. Then the benefits are described in a table like this. The idea, the first point I would like to call your attention to in this exercise is that the important point is that you build the table presenting all the data on your own. Okay, this is important. This is important because the process of assessing a project is specifically contains this step. You have to create a table with all the information you have in order to be sure that you understand everything. The order is the result of your work. So let's clone the table we have there. We already have the table, so we will give the same order: cash flow, concept. Okay, we will introduce here, as it will be necessary, another one with units. Okay, so let's start collecting information. The land necessary for the runaway. Buying land. Buying land for the runaway has units as dollar. You pay once when you buy, and the total amount is 300,000. Okay. Okay. Then the construction cost for the runaway extension. You have the land, but you have to build the runaway. Construction. Are again dollars. 600,000. Okay. This is what we know about this. But there is an additional annual maintenance fee. Okay, I will start. So now we have an additional cost that is expressed in dollar per year. It's maintenance cost. and this is paid every year for this amount. Okay. Okay. If the runaways are extended, a small terminal will be constructed. An additional cost for construction cost for the terminal. This is construction cost. This is for the runaway, and this is for the runaway. Okay. The construction cost of the terminal is this amount. Okay. And this is again dollars. The maintenance cost of the terminal, it's here. Okay, not the runaway, but the terminal. Okay, has again the units are dollar per year, annually paid. Okay, and this will be 70,000. Okay. Finally, the project increasing flights will require the addition of 2 air controllers at an annual cost. Air control cost. Okay. This is again dollar per year. Okay. So now we have a clear idea of what are the consequences of our decision. Okay. Okay. Something like that. We'll have additional annual cost included here and total cost included here. So we'll probably do better if we separate this. We'll put it here. Okay. And then we add this. This has a total value of um, 12, 12. Yes. Okay, this will better organize like this. Correct. Okay, and then we'll have, apart from that, something like this. Okay, and for the annuity, we will have this is looking at an additional one organized on the right. Okay, then 7, oh, 729, 120, F5. Okay, so we have this total amount per year plus this. Okay, about the benefits. Okay, annual benefits can be also calculated here. Okay. We can now obtain the benefits per year. Okay. we can add the annuities of the cost, we can add the annuity, the total cost of investment, and now we can add all the benefits. Okay. 12, 14, 4, 4. Okay, this is no, 5, 5, 5, 10 menos 1. Okay, total benefits. Okay, now we need to apply the required mathematics in order to summarize all this. Okay, the problem with the benefit cost ratio is that we can apply it in two different ways. If we have a look at this table, we'll have a clear idea that this is what we're going to obtain as revenues, this is what we're going to pay as cost. Okay, so if we use this approach, okay, approach one, conventional, we will make a quite simple analysis. We'll say that present worth of benefits, revenues, is obtained as a function of R, obviously, will be present value of an annuity for a value of for a given rate of discount during 20 years, as described here. Okay, 20 years. I keep the rate of discount as a parameter because I will use it later. Okay, we know the formula of this, and we can calculate it. We can introduce manually. You remember, it's something like this, but it's actually not necessary as far as we have maxima that will help us for this. Okay, if we open maxima here and ask, please tell me what's the expression for present value of an annuity Q R T or N, better N. Okay, we know the expression. Okay, okay, this is 1 plus R up to N minus 1, and here it is R times 1 plus R up to N. Okay, we know this expression, we can obtain it. But in our case, we also have the numbers, so we can do it. Present worth will be P over A (0.1) in our case, and equal to 20 years. Okay, so we know it's 4 plus 7, 3 to 4. Okay, this is the present worth of the revenues. Okay, we'll call this revenues. Okay, now what is the present worth of the cost? Okay, actually there are two components of it, but we will obtain directly. Present worth of cost is equal to present worth of initial cost plus present worth of an cost. Okay, what's the present worth of the initial cost? Okay, we know directly, we can just add 1 And what's the present worth of the annual cost? Again, the annuity of, and the amount is calculated here, 1,975. Okay, and in our case, this will be cost costs equal to plus P over A. ¿No? 197 elementos, ok, at the 1 during 20 years. That's pretty simple. So the cost is this amount. I will copy directly and I will just round to 1 up 9 here. Okay. Then we can directly obtain rev over cost. Oh, sorry, not here, but here. Rev over cost will be 1.59. Okay, perfect. ¿Cuánto era esto? 428. Okay. So, benefit cost ratio. Benefit cost ratio version 1 will have a value of 1.49. Okay? Sorry, 59. That means that for each dollar you spend in the project at any moment, you obtain an extra half dollar, 50 pence, 60 pence. Okay, that's perfect. We have a clear information about what is the revenues generated by the project. That's it. We are comparing this with the inherent cost. What is the actual amount of money we have to spend, either at the beginning, either at the end? Okay, so it's an accurate measure of the situation. But one can discuss this because at the end, when you take the decision, you are only investing. And anything that will happen after that will be financed through the revenues itself. So essentially, you don't need to go to your box, to your bank box, obtain money and pay for it and finance it because you will obtain directly from the revenues. So we can assume that someone proposed a different solution. And what is the different solution? Okay, approach 2. It can be understood that this is the one that's called modify. We can now present the result differently. The present worth of the revenues. Okay, it's something similar to that, but let's think of present worth of net revenues. And this is equal to net rev, okay? And this is equal to revenues minus present worth of operational cost. Okay, so then what we can say, okay, the present worth of the revenues are known, is something like this, and present worth of the operational cost is something like this. Okay, if we use this expression for a given value of R, we'll get this amount. This will be called net rev. Hmm? Okay, and then the present worth of the cost is already known because it's present worth of investment cost, capex, will be equal directly to 1,000. Okay, then the benefit cost approach 2 will still be interesting, will be consistent, will give us important information, but this information will be expressed with different figures. So we have this, then we divide by a net revenue. And suddenly we discover that the actual ratio over the investment we have to do now is much more interesting. We are obtaining 2.4, $2.5 per dollar. Okay, the net revenues we will obtain, that is the benefits, the actual benefits we will obtain, will be more than twice the investment we need. This is much more important to describe the situation of the initial investor, but the other one, the first one, will be possibly more powerful in order to show the actual performance of the cash flow associated to the project. So two alternatives, both of them say the same about the project, but measure with different units. The problem here is that what happens if we add another component, for example, an special investment, additional cost, that will reduce the air control cost, the sanity. Okay, that's possible. Then, once we have this data already processed, we can consider that this is an extra cost, okay, in both cases, but the person who has used this approach will consider that this improvement implies savings in the operation. That means less operational cost. And the person who has used this approach will consider that what we are obtaining is an extra revenues because we are saving in operational cost due to the investment. So for the way you treat it will be totally different. But once the numbers have been produced, sometimes you don't keep the memory how well they compute. So someone may switch from one approach one, then you modify it, acting as if the initial ratio was obtained through the second approach, and then you will be everything will be a mess. Okay, so it's important to keep track of the procedures followed in the project. Otherwise, you will have plenty of problems. Okay,